Hello everyone, welcome. And for today, I will be talking about graphing logarithms or logarithmic functions. But before we discuss that, let us just first recall the exponential function. Okay, let's just graph that real quick. Okay, this is your exponential function. It has the y-intercept at 0, 1. And it also has its asymptote, horizontal asymptote, at x-axis or y equals 0. This is the graph of y equals b raised to x. That's exponential function. Okay, suppose we will graph its inverse. Okay, the word is inverse. Okay, you know that when we are graphing the inverse, we simply flip x and y, right? So your x becomes y and your y becomes x. So to sketch its inverse, the inverse of x-axis or the horizontal asymptote is the vertical asymptote, right? And that's going to be the y-axis or x equals 0. All right? So your x equals 0, sorry for that. Okay, y-axis or x equals 0. That is the inverse of y equals 0. It's x equals 0. And for this point right here, okay, when we flip 0.01, that becomes 1, 0, right? So it's gonna be here. There. Okay, so let's just try to graph the line y equals x. Because that serves as the mirror for our graph. Okay, so the graph would look like this. It's going to approach this line. And, oh, sorry for that. Assume that it's perfectly done, okay? All right, so that's how the graph of the inverse of the exponential function looks like. And actually, this graph right here is the graph of logarithmic function, okay? The graph of y equals the logarithm of x with base b, okay? So in other words, we can say that logarithmic function is the inverse of exponential function, okay? Just remember that when we're dealing with logarithmic function, we look into the vertical asymptote, not the horizontal asymptote. And there's an intercept, and that's on the x intercept, on the x-axis, right? Not on the y. Okay, let me just discuss that real quick. All right, suppose we're going to graph the logarithm of x with base 3, okay? But before we answer that, let us have a quick comparison between graphing exponentials and logarithms. Well, this will be in terms of finding the asymptote and determining where the graph will probably contained. Okay, so let's first take a look in this exponential function. Okay, we know that this d value determines your horizontal asymptote, right? In logarithm, we use the value of c, and that's now your vertical asymptote. Okay, what about this a value here? So let me just try to graph real quick this one. Let's say this is your x, this is your y. For example, the d value here, for example, is at 1. At 1. So we can say that there will be an asymptote at y equals 1, right? So therefore, how do we know if the graph will be above of this line or under this line? Now, if your A is positive, then we are sure that the graph will be contained above that line, right? But if your A is negative, it's going to be below that line. Okay, what about in the logarithmic function? We know that the C is a vertical asymptote. Let's say we have a vertical asymptote at, let's say at here, x equals 2. For example, that is your value of C at x equals 2. Okay, now how do we know if the graph will be on its right or on its left? Now we look into its B value, not your A value, okay? So here, if the B value here is positive, then we are sure that the graph will be contained to the right of this line. It's probably like this. But if your B value is negative, then it's going to be to your left. Okay? All right, so let's try to graph now the function. Let me just remove all of this to have a better look on our graph. Okay. Okay, before we answer that, let us just try to determine the values of A, B, C, and D in our given function. So our A is equal to, your A is 1. Okay, because there's actually 1 here. Okay, and then your base here is 3. This one is 3. And your B value, so there's actually 1 here. Okay, it's your B is equal to 1, not 0. Okay, and your C value is, so no number, so that's gonna be 0, and also we don't have D value. Okay, we have to recall that we're going to find the vertical asymptote, and we can determine that by this C value, right? Okay, this C value, so y equals 0. X equals 0, that's your vertical asymptote. Okay, so let's graph that in blue. This is x equals 0, okay, or y-axis. All right, so here we know that the graph will be on its right or on its left, right? But your B is positive, so it's on your right. And since the graph has an asymptote at x equals 0 or y-axis, so therefore the graph will never touch that line, okay? So we can conclude that there will be no y-intercept. So what we will look into is the x-intercept. Okay, let's find step number 1, find the x-intercept. And we know that we set y be equal to 0, or your f of x be equal to 0, right? So 0 equals the logarithm of x with base 3. Okay, let's just try to recall something before we proceed in answering that. Now, in logarithmic function, y equals the logarithm of x with base b, we can actually express this in exponential form, right? How to answer that? So that's your base actually, and the exponent is your y, because we already discussed that the logarithm is just an exponent, right? So b raised to y, and it's equal to x. And we will be applying that in finding the x-intercept, okay? So your base is 3, the exponent is 0, and that should be equal to x, okay? So what is 3 to the 0? And it's equal to 1. All right, so we have an x-intercept at 1. It's gonna be here. Oh my goodness. There. Okay. So the graph would probably look like this. So if you can go back to the graph earlier, as you can see, they are the same. We have the vertical asymptote at x equals 0, and it has the x intercept at 1, right? So same as this. So that verifies that this is really the graph of a logarithmic function. So let us just try to find or determine the other components or informations here. Let's find the domain. As you can see, the domain is just the graph is only contained to the right of 0, right? So therefore, the domain will be, it can never be negative because there's no graph on its left, right? So the x values are a set of all x such that x is an element of real number, but your x values are greater than 0 because your graph is contained to the right of that number 0, okay? And for your range, as you can see, you can extend this more if you want, or extend this here more, and that means that the range will be all real numbers, okay? No limitations. Okay, the set of all y such that y is an element of real number. Okay, what else do we need here? The end behaviors. Okay, for the end behaviors, okay, as your x values, look at that, your x is going positive, right? So as x approaches infinity or positive infinity, let's just try to remove that, okay? The graph is what? F of x is approaching infinity as well, or positive infinity. And then here, the other one, as x is approaching 0, because you can no longer go beyond that 0 because there are no graph on that side, okay? As x approaches 0, from which side? From the right side. So there's plus here. So if that's from the left, so use minus sign, okay? So as x approaches 0 from the right, look at the graph, it's decreasing. F of x is approaching negative infinity. All right? Okay, what else do we need here? Okay, and the interval. For the interval, you just look at the graph, you read the graph from left to right. As you can see, from left to right, it's increasing, right? So therefore, but from which interval? It's from here, from 0 to infinity, right? So from 0 to infinity, or positive infinity, the graph is increasing. Okay, so in my next video, I will be discussing more about these logarithmic functions, or I mean graphing logarithmic functions. Okay, thank you.